Welcome back. This session will continue the discussion about phasor analysis. Let's solve one more problem. Suppose we have a simple RL circuit. Here R is 4 ohm. 4 ohm. Inductance is 0.2 Henry. And voltage Vs is 20 sine 10t plus 30 degrees volts. And our goal is to find the voltage across this inductor and current flowing through this circuit. Okay, this is a circuit, series circuit, so same current will flow through all the branches. All right, so let's find the these voltage and currents. Now what we'll do, we'll convert this circuit into phasor domain first. So what will be the equivalent of this in phasor domain? So in phasor domain, we replace the voltage source by its equivalent phasor, voltage phasor, resistor by its equivalent phasor, and inductor by its equivalent phasor representation. So let's write the values. Now we can write 20 sine 10t plus 30. We can convert it into a cosine wave first, then write the phasor, or we can start with the sine directly. We don't have to convert it every time. Okay, we can do it directly. We can start with the sine itself. So we can say the voltage source is simply 20 at an angle of 30 degrees, just like we used to do it. There's cosine waves. Right, so we'll start with the sine itself. So we'll assume our source is sinusoidal. So resistor is replaced by 4. And what will be inductor replaced by? Inductor will be replaced by j omega L. So j omega L here will be j. Omega here is 10. You can see from the source. So it's 10 multiplied by 0.2. That's equal to 2j. So impedance offered by the inductor is 2. Now we'll write V will write as capital V, and I will write as I phasor as capital. Okay. Now, as we discussed it in the last section, all the techniques that we have learned are the methods that we used in this resistors are now valid for impedances. This 4 is an impedance, this 2j is an impedance. So whatever techniques or laws or approaches that we have learned for the resistance are valid here. So what we'll do, we'll directly solve the circuit. We'll find the voltage across this 2j impedance by using the voltage division rule. So here we'll use voltage division rule. Voltage division rule. This rule says if we have to find the voltage across R2, then V2, let's call that voltage V2. Voltage across R2 is simply equal to R2 divided by R1 plus R2 multiplied by the source voltage. So if we assume now our resistances are impedances, so what will be the voltage division rule? So if we are finding the this voltage across Z2 impedance, it will be Z2 divided by Z1 plus Z2, where Z1 and Z2 are the impedances. Here Z1 is 4 ohm and Z2 is 2J multiplied by Vs. So let's apply this and find V. Find this V. So what will be V equal to here? V will be simply equal to the impedance of this element is 2J. It will be 2J divided by impedance 4 plus 2J multiplied by the source voltage. Source voltage is 20 at an angle of 30 degrees. Okay. So this is the voltage division rule for this circuit. Okay, this is the voltage division rule for this circuit. Voltage across the impedance 2J is simply 2J divided by 4 plus 2J multiplied by the source. Okay, now since so from here we have complex number, so we have to manipulate these complex number. This is in rectangle form, this is in rectangle form, this is in full form. Let's convert all these into full form. So what is the equivalent of 2J in this polar form? It will be 2 at an angle of 90 degree, right? So this is the polar equivalent of 2J. What's the polar form of 4 plus 2J? It will be under root of 2 square plus 4 square. That is 4.47. Please check the calculations yourself. At an angle of then tan inverse 2 by 4 is 26.56. And then 20 at an angle of 30 degrees. Okay, these are in degrees. Now you can multiply this. So this is 40 at an angle of 120 degrees divided by 4.472 at an angle of 26 point. So this is the voltage across this 2J impedance. Now if you simplify this, so V will be simply equal to 40 divided by 4.472 is 8.944. Then 120 minus, so angle will be 120. 120 minus 26.56 degrees. So this will be 8.944 at an angle of 120 minus 26 point this. So this will be, I think, 93.43. Please check the calculations one more time. 44. I think it should be 44. Not 43. Please check the calculations yourself. Okay, so this is the phasor voltage across this impedance. Now our goal is to find V, small v, that is V of t. V small v means here we have to find voltage with respect to time. So how do we convert a phasor voltage into time domain form? We write the amplitude. Amplitude here is 8.944. Then since we started with sine, this is very important. Since our source is sine, so we also write this on this. Voltage across this will be in terms of sine omega t. Omega is 10 t plus 93. Phase is 44 point. Okay, that's how we write. If we started with sine, we'll write the answer in terms of sine. If we started with cosine, we'll write the answer in terms of cosine. Okay, that's very simple. Okay, this is the voltage across this inductor. Now, next quantity that we need to determine is find I. Now, what's the relationship between phasor I and phasor V? You can see from Ohm's law, we know voltage in impedance Z is simply given as voltage is equal to I times Z. Here Z is simply 2J. Okay, this is the impedance offered by the element Z. So Z is 2J. So how we will write this? So we'll say simply we'll use Ohm's law. Ohm's law says that the voltage across this 2J impedance multiplied by I. Now we need to find I. So I is V by 2J. Now how much is V? V is 8.944 at an angle of 93.44. Now we'll write 2J in the polar form. 2J equivalent of 2J is simply 2 at an angle of 90 degrees. So if we simplify this, 8.99944 divided by 2 will simply be equal to 4.472. Please check this one more time. Then 93.44 minus 90 degrees. We simply subtract the angles in division. So I will be simply equal to 4.742 at an angle of 3.44 degrees. So this is the phasor current. Now we need to find I of t. So I of t will be simply equal to amplitude is 4.72. Again, since we started with sine, so since our reference is sine, so we'll write the answer in terms of sine. So we'll say sine 10t, frequency is 10 plus, then angle is 3.44 degrees. amperes. So this is the current flowing through this series circuit. Okay, I hope you understood this. So this is very, very simple, right? Okay. Now next what we'll do, we'll solve one more problem. Let's consider one more problem of, let's consider another series circuit. This time we'll consider RC circuit. Now the voltage here is simply 10 cosine 40. So we have S of t is simply 10 cosine 40 and resistance is 5 ohm and capacitance is 0.1 farad. So we have to find again voltage across this capacitor and current flowing through this circuit. Okay. Now small v means simply v of t. Small I means simply I of t. Okay. So what we'll do first, we'll convert this into the phasor equivalent. So phasor equivalent of this circuit will be simply, we'll replace these quantities in the circuit by their phasor equivalent. So resistor will be replaced by 5 ohm. Capacitor will be replaced by 1 by j omega c, and source will be replaced by Vm at an angle of theta. How much is Vm? Vm for this circuit is simply 10 at an angle of 0. Why 0? Because there is no phase here. So 10 at an angle of 0. So we'll assume the reference is cosine. Now, what is the value of the capacitor? Capacitor will be replaced by 1 by j omega c. If you find this value, 1 divided by j omega is how much? 4 here multiplied by 0.1. So this will be 1 by 0.4 j. 1 by j is simply minus j. So it will be 2.5 minus j. Okay. So the impedance offered by the capacitor is minus 2.4 j. Then we'll replace small v by capital V phasor and current small I by capital I. Again, we'll use the voltage division rule. Why? Because there are two impedances connected in series here. So simply we'll follow the voltage division rule. So we'll say V will be simply equal to the impedance of the element is minus 2.5 J divided by total impedance, that is 5. So there's minus, let me write minus 2.5 J multiplied by source voltage. Source voltage is 10 at an angle of 0. Now you can see these are simply complex numbers. So we need to, okay. So we'll convert these into the polar form. So it will be minus 2.5 J. We can write as 2.5 at an angle of minus 90 degree at an angle of 10, 0 divided by 5 minus 2.5. So it will be under root of 5 square plus 2.5 square. And that comes out to be 5.59. Please check the calculations one more time at an angle of minus 26.56 degrees. Okay. Now we'll simplify this. So what is the simplified version of this voltage? So 10 multiplied by 2.5 is 25 at an angle of minus 90 degree divided by 5.59 at an angle of minus 26.56. Okay. So 25 divided by 5.59, that is 4.47. Please check the calculations one more time at an angle of minus 90 plus 26.6. Why plus? Because it is minus here. So when it comes on the numerator side, it will be plus. Okay. All right. So this is the voltage. Voltage will be simply equal to 4.47 at an angle of minus 90 plus 26.56. It comes out to be minus 63.44 degrees. So this is the voltage phasor. So this is the voltage across this capacitor, but phasor in phasor form. So how do we convert it into this time domain form? We say V of t or simply V that is named as small v is simply amplitude is 4.47. Since we started with cosine, so we write cos. Frequency here is how much? 4. So we'll write 40 plus minus 63.44 degrees. So this is the voltage that we needed to find across this capacitor. Okay, see how simple it is to calculate in terms of phasor or phasors, right? It becomes mere manipulation of complex numbers. The next quantity that we need to find is I. Now, what's the relationship between I and V? Since the same I is flowing in this impedance, so we'll say V will be simply equal to V phasor. V phasor will be simply equal to I times Z, where Z is the impedance of the element. I times Z is minus 2.5 J. So what will be I? I will be equal to V divided by minus 2.5 J. So what's V? V phasor is 4.47 at an angle of minus 63.44 degrees divided by 2.5 at an angle of minus 90 degrees. Minus J we can write 1 at an angle of minus 90 degrees. Okay. If you simplify this, 4.47 divided by 2.5 comes out to be 1.788 at an angle of minus 63.44 plus 90. Why plus 90? Because it is minus here. So when it comes on the numerator side, it will be plus. So I phasor will be simply equal to 1.788 at an angle of 63.44 plus this is 26.56 degrees. So this is the I phasor. So we need to find I, which is same as I of t, will be equal to amplitude of this current is 1.788. And since we started with cosine, frequency is 40 plus 26.46 amperes. This is the current flowing in this circuit. Okay. Now see how easy the calculations become once we convert the circuit in the phasor domain. Okay. It is mere this manipulation of these complex numbers. So if you know how to manipulate or do the algebra on these complex numbers, computation has become very easy. Okay. All right. Let's end this session here.